Welcome to Chapter 11, Public Key Infrastructure and Encryption. Learning Objectives and Key Concepts. Learning Objectives. Implement a PKI, Public Key Encryption, and Encryption. Solutions to ensure confidentiality of business communications. Key Concepts, PKI, components and their roles, non-repudiation and digital signatures, PKI certificates and authorities, encryption process. Public key infrastructure provides a secure mechanism for business and e-commerce transactions, a community of trust, infrastructure to make the internet safer, a level of security needed for multi-layer security systems, framework that consists of programs, procedures, and security policies, employs public key cryptography and X509 standard digital certificates for secure communications, is a hybrid system of symmetric and asymmetric key algorithms. Components of PKI: Certificate of Authority, Registration Authority, Certificate Repository, Certificate, Validation, Key Recovery Service, Time Server, and Signing Server. Encryption and Cryptology. Encryption, the process of applying an algorithm to clear text or plain text, data resulting in ciphertext. Crypto system, a hardware or software system that provides encryption and decryption made up of encryption algorithm, keys, software, and protocols. The secret piece of the crypto system is the key. Encryption and Cryptology. Encryption process. We start with clear text, we go to encrypted text, then we go to ciphertext, then we decrypt it, and then we have clear text again. Key thing is you have to have an encryption key and decryption key. Encryption and Cryptology, Symmetric. Symmetric algorithm use shared keys for encrypting and decrypting data. Symmetric encryption systems allow only the user who have the secret key to read the data. Symmetric key systems encrypt and decrypt information more quickly than asymmetric systems. Symmetric key systems require a secure method to create and exchange the secret key. Each pair of users require a secure method to create and exchange the secret key, making the key management difficult as a number of pairs of users increase. Encryption and Cryptology Symmetric. Shared key, you see we have the clear text, encryption, and then the same key is used for decryption. Encryption and Cryptology Systematic. Asymmetric algorithms use pair-related key, private and public, for encryption and decryption. Public keys can be known by anyone. Public and private keys are related, and anything encrypted with one can be decrypted with the other. So as you see, I start with clear text. You have the recipient's public key to encrypt it and the recipient's private key to decrypt. Number of keys needed for different group size. So if there's only 2 in a group, you need 2 keys. For the asymmetric, you need 4 keys. And as you can see, as the number grows, especially in the symmetric keys, if you have 100,000 users, you need 5 billion keys, which it gets quite a lot. So this is what we need to look at. Business requirements for cryptology: ensuring software and data integrity, ensuring secure collaboration between entities inside and outside an organization, ensuring secure cloud computing, provide secure transactions with consumers. Best practices for PKI users within large enterprise and organizations. What are the business drivers for using PKI within the organization? What applications will be used using PKI? Is it being used for secure email, communications, or transactions? What does PK architecture look like, and how will it be used? What impact will this implementation have on other users, customers, and business partners? Where will the infrastructure reside? Can the current organization infrastructure support the technology? Digital certificates and key management. Digital certificates used by individuals and servers to provide unknown third parties with a known secure copy of the public key. Encryption. Certificate authority. Issues digital certificates after verifying the identity of the end user. Registration authority. Verifies the identity of the individual initiated that certificates process the CA on behalf of the users and perform certificate lifecycle management. This is what a digital certificate looks like. Digital certificate management, domain validated. Certificates affirm that the certification was issued to someone controlling the domain name. Includes this in the certificate. Organization validated. Certificates go deeper and verify the identity of the business named on the certificate. Extended validations certifies that the provides the strongest degree of trust, verifying the physical presence that the certificate is there. Digital certificates and key management, generation, distribution, storage, usage, recovery, termination, and archival. Digital certificates and key management. Key should be long enough to provide the necessary level of protections. Key should be random, and algorithm should be useful key space. Key's life should correspond with the sensitivity of data. The more key is used, the shorter its lifespan should be. Asystematic cryptology requires longer keys than systematic cryptology to achieve the same level of security. Diffie and Hellman, a key exchange, enables two systems to receive systematic keys without a previous communication, provides key distribution, does not provide encryption or digital capabilities. RSA, asystematic encryption algorithms, developed to prevent man-in-the-middle attacks. Most provide public key algorithms can be used for digital signatures, key change, encryptions, and decryptions. Elliptical curve crypto system provides the same functionality as RSA, but is more efficient. Attribute keys. Public key is available to all. Private key is kept secret to the owner and never shared. Sender and recipient share a secret key. Key length required. Asymmetric is longer. Symmetric is shorter. Examples of algorithms: asymmetric, RSA, Diffie-Hellman, ECC. Symmetric is DES, 3DES and AES. Key exchange: asymmetric, easy to deliver public key. Symmetric requires sharing keys in advance through another secure mechanism. Encryption speeds: asymmetric is slower. Symmetric is faster. Security services provided: asymmetric, confidentiality, integrity, authentication, and nonrepudiation. Symmetric, confidentiality, integrity, and authentication. Certificate of authority: a trusted organization that maintains, issues, and distributes digital certificates. CAs may be internal or provided by a third party. Certificate revocation list: a list of invalid certificates. Online certificated status protocol: a method for live interaction and verification of certificate status. Certificate practical statement: provides details of business processes by the CA to verify the identity of the certificate owners. Here's a list. Here's the different way everything comes together. As you see, step 1, Alice makes the request to the RA. Step 2, the request information from Alice. Step 3, the RA requests digital certificates from the CA. Step 4, the CA creates the digital certificate and securely sends it to Alice. Step 5, Bob's requests Alice's digital certificate. Step 6, Alice sends the digital certificate to Bob. Bob verifies the digital certificate. Ensuring integrity, confidentiality, authentication, and nonrepudiation. Confidentiality ensures that only the intended recipient can read the message. Integrity ensures the message received, the message was sent. Authentication allows someone to prove his or her identity to another. Ensures a third party can verify that message came from the purported sender. Using digital signatures. Digital signatures, signing an email allows receiver to verify the contents were not modified after the data was sent. Digital signatures provide non-repudiation. Digital signatures can be used to identify if the user has signed off on approval of a particular document. Cryptograph hash function creates the hash value. When it gets to the other side, the hash value should match. Using digital signatures, same thing. Once you add the signature, it should match. PKI is a strong authentication method. Provides integrity, confidentiality, authentication, and non-repudiation in a single framework. PKI is not an answer to all security questions or concerns. It does not provide authorization. Does not ensure that the end users can be trusted. What are potential risks for PKI? If PKI management is mishandled, the entire PKI system could fail. Managing a secure environment with multiple keys can multiply entities can be overwhelming. Properly maintained PKIs can come with financial burden. Implementation of the business of cryptology. Encrypting hard drives as preventive measure in case a laptop or other mobile device is stolen. Encrypting removable devices such as a universal serial port. Encrypting instant messaging communication. Encrypting files transferred within and without the network. Encrypting highly sensitive data. Encrypting information on mobile devices. Distribution of keys within the organization is vital for key management. Organizations must ensure the keys are safe and distributed securely. Some organizations may choose to outsource these services. Outsourcing can be expensive. There are many systems, communication path, a file that needed to be encrypted within the organization. In-house key versus outsourced key. Total cost associated with an IT resource and knowledge. Manage keys in-house requires an organization to manage the service level of agreement in various businesses. Can an organization trust an outsourced key? What level of support can be outsourced? Certificate authorities and digital certificate management. All digital certificate implementations are done through the root CA. Root CA signs every certificate. Subordinate CAs can be established from specific needs. Policy authority, certificate manufacturer, certificate issuer, revocation manufacturer, registration authority, authentication service, and repository. Why outsourcing may be advantageous. Communications with suppliers, customers, and business partners should be seamless. Organizations may be geographically dispersed, and it would be more advantageous to have multiple CAs available at all these various locations. Organizations do not want to take on the costs associated with managing CAs on site. Risks and issues with outsourcing. Insecurity placed around the individual CA. Is access granted to any employee who are there? Strict constraints around it. How does organizations know that they can be trusted? An organization may want to control its own CA if a higher security requirement, not possible in outsourcing. Organizations with high security requirements more apt to manage the CA locally where there are more control. Best practices. What database will be used for PKI? What are the legal and policy considerations for CAs? What are the trust relationships with how they are established? How will PKI be deployed? Who will have access to the system, and how will this be monitored? Case study examples. Private sectors. Perot Systems rolled out a PKI in lessons learned. Chose recognized industry leaders as vendors. Set clear expectations for management and end users. Make sure PKI can be maintained. Ensure ease of rollout. Public sector, United States Patent and Trademark Office implemented PKI to achieve the following: confidentiality for information exchange, integrity in patent application, authentication with whom the Patent Office deals with electronically, VeriSign creates issued to a person posing as Microsoft employees. Examples show how KPI failed because the CA issued certification without appropriate verification. Summary: we did PKI components and their roles, non-repudiation and digital signatures, PKI certificates, authorities, and encryption process.